It's 6 p.m. here at the top of the hour. So, in honor for everybody's time, let's start. And as people join, they could again get into the talk. So, in every project, once you start having a lot of data, uh, you begin having slower queries, a slower response time from your database. And that's because for each query, even though uh, you are selecting from a specific table with some word clauses, uh, there are two things that happens. The first, the data is not is not saved in disk in order, and the second thing is that uh, the query has to go all through the data so it knows which things it can it's part of the query or not. So if you have a 1 million row table, it will have to go through the 1 million rows to see if they are part of the query response. And as it gets bigger and bigger, uh, it's going to start making your queries longer. So there are a couple of improvements that we can do. The first one and the easiest one is we can create indexes. So if I'm going to make a similar with in a library, you have all your books and you have thousands of books on the library, and in order for you to find a specific book, a specific topic, it, back in the day, we used to go to a card system where you find the author and it will say, okay, that book will be on row 100, and I will give you the approximate position, and that way you can find a book you were finding. So the indexes does exactly that. Makes will tell the database, your record is approximately in this space in the disk. That's one thing we can do. Now, when the data starts becoming bigger and you start having more and more data, uh, having only indexes is not enough. Uh, we need to start making use of a partitioning system where we start dividing the data into multiple tables that are related, and and we will be looking at that later on the presentation. And the final that I'm going to explain a little bit right now, but it's out of scope for this presentation specific, is that you can shard your database. But sharding is, for example, in an organization like Chingu, people in America and people in Europe will have very different response times. So you divide your database in America, in Europe, in Asia, in Australia, etc., so people can access their data quicker. Basically, that sharding is dividing your database like that. Each one of these improvements have their benefits, but also have their costs. So let's talk about indexes. Uh, Indexes will speed up our queries. as I told you, with the library analogy that I made, is the card with a will say to the query, here are the results, and it will pick from uh, those pages the data it needs. But indexes can and be costly to create. Uh, it uses space in disk, can cost memory. And also, when you are working with mutations like insert, update, delete, it has to maintain the index. So every time that you modify the index, you will need modify the data. You will have to modify the index. So those are processes that have to happen, and that are at costs. So let's create some data on a database, on a fresh database. So here we have an empty database. I'm going to paste all these files, a link to this project on the town hall chat channel, so you can access. And we have all these queries that we will be working with. So this script creates a users table, an issues table, comments and publications. It makes sure that it clears any existing data, and it inserts a different number of records per table. So for it's 100 random users, 1,000 random issues, and so on and so forth. So let's copy this to the database, and let's give it a minute so it will create everything, and we will have the data we can work with. Uh, so there are, while it's being created, I will continue talking. There are two kinds of indexes that we can create. There are the clustered indexes and the non-cluster indexes. The cluster indexes, it reorders the data on the database on a specific index. So it will make your queries much faster. Non-cluster, and you can have, for that reason, you can have only one cluster index per table. Non-cluster indexes are just pointers to say where the data is, and you can have many non-cluster indexes per table. So let me see how. Okay, now we created everything, and there's in Postgres you can use a command that's called plain analyze, and we can give it a query. So let's say select star from comments where created at is equal to let's say 2022 2026 01 04. Okay. So it gives us this information here. Alex is asking what the B is. This is in Postgres. But most of the commands, the explain analyze command is of Postgres. I don't know what's the for my MySQL or other databases, but all databases have these commands, so you can visualize what's happening with your query. So here there's it says, okay, it's doing a parallel sequential scan. So it says it's doing a sequential scan on all the rows, and it took 267 milliseconds on this query. So if we say create index, I like to call my indexes. Now we give it a name. So, this is the command to create an index. Create index with the index name on the table and all the columns names that we want to give it as be part of the index. So we go here. As I create ex, I like to call that my indexes ix, name of the table, and then all the columns that I want to use them. So I can say created at and on comments and created at. So now I created the index, and if we run the same query as before, it says it's using an index scan, and the execution time went to 0.08 milliseconds. That's the power of the indexes. As you can see, it goes way down the time. And this is a 1 million row size table. So it's a really good improvement. But as I said, there are costs on, I have this query here that will tell us how much space each index that we have, right, is on the database. So as you can see here, the index we created uses around 21 megabytes of space. So there's the cost. So everything, and if I try to insert, it will have to find the place to insert. So that takes time too. So those things are starting to cost when you create indexes. Questions so far? Okay. So this table comments has relations with issues and users. So if we let's drop the index. Yeah, drop index. Uh, so we can have a fresh table that we can work, and we can say select uh, star from, I would say, count star from comments where issue ID equals 1. Okay, we have 100 rows, but if we have the explain analyze, it has an aggregate cost, and it took around 200 milliseconds. If we create an index, comments on comments and issue ID, and we run again the query, we see it goes way down. It's it's a lot less time, but we have here an index only scan. Since we are aggregating data, it doesn't need to access data on the on the disk. It knows that it has a certain amount of data. So that's you have to work with. Let's create. Let's drop the index again. Comments issue ID, and let's make the query and user ID equals 1. Okay, we have the parallel query and all the things we've been seeing time and time again. So if we create an index, comments, let's say issue ID, user ID on, or comments issue ID and user ID. Okay, and we run. We see we are using the index only scan and all the time, all the benefits. But there's one thing we can see here. What do you think will happen if I run this query by using the issue ID? Any guesses? Will it use the index? Will it not use the index? Will I have to create an index for the issue ID? What do you guys think? Okay, let's run the query. Don't know. Okay, it still uses the index. You can see it's using the index comment issue ID user ID. That's one important thing. And it's using the index. But if you use the user ID, it does not use the index. So using you can add multiple columns on the index, but you have to know that if it has if you're looking for the, in order of the index, so let's go here and let's write. So we run create index ix comment issue ID user ID. So if with this, if I have a query that's using only the issue ID, it will use this index because it's the first one here. It does not use the user ID because it's the second, so it's not doesn't know how to use. So when you use composite index, it's important to know these things. So so now let's go back to the cluster indexes. As we said, it saves the data. It orders the data on the database, so it gives more improvements. But in MySQL, I know because I looked for it uses the primary key as the cluster index. Postgres doesn't have any cluster index by default, and you have to create it manually, and you have to maintain them regularly. So I think that's a benefit over MySQL in Postgres in this case, because not always you want to use the primary key to have the order. Maybe you have a long historic data table where for you it's more important to have that data ordered by date so you can access more quickly. So let's see. Let's see at the publications table. We are going to, so we can say um, select, plain, analyze, select bar from applications where dates is greater than 2020, 2025, 1201, and date is less than 2026, 0101. So in this query, we are analyzing all the data, retrieving all the data from the publications on December. If we create an index, publications, date on publications, say date. You see, we are now having time to create the index because this is a 10 million row. We are having more time, and so everything is slower. And we run again the explain analyze. It's still doing a parallel bitmap head. So it still is slow. All the things are still slow. So we can create a table, a cluster with this index. So we can say cluster publications using the publications date. This will take a time because it's going to start sorting all the data on the table, those 10 million rows, with using this key. So it takes a little bit of time. Let's give it a second. So any questions so far while we wait? I don't know if I confused everybody or I was explaining very good.
Yeah, I have one question here. So
Okay.
the when you run this command, does that publication date index have to be created before you do the cluster command?
Yes, you have to have an index before you create a cluster command.
Again, that's creating like a whole new table, right?
No, it's not creating that table.
Oh,
Right
okay.
now, we're yeah. So the data is inserted randomly on disk. So what we're doing now is sorting all the data in the disk, the physical disk. We're sorting the data on using this index.
Okay, so it's taking the publications table and just reorganizing it in the order of whatever that index is.
Exactly.
Okay, cool.
So I have a question, Andres.
Go ahead.
Oh, I'm sorry. So does that imply or does that mean you can only have one clustering index per table?
Yes.
Cool.
There's only
Thank
one
you.
clustered index per table. You can have as many non-clustered index because they are only pointers. But once you sort the data, it's stored on disk. You can only sort by one criteria. So let's give it a second, taking a little bit more. So here on we were saying here that the cluster index are ordered the data on disk and can only be one cluster index per table. And the non-cluster indexes is adds the pointer to each value It can be created manually. The indexes are saved on disk, as we saw, and are updated on every insert, update, or delete. It's taking longer than I expected. Uh, let's go. Let's continue. Uh, might we might have to stop this because it's taking a little bit longer than I expect. So the next strategy we're using uh, to improve our queries is reducing the table size. How we can reduce the table size is with is partitioning the table. So it will improve also the all the mutations because we're going to be creating new. Now we're going to be creating new tables, so we can use the data. So you can have partitions by range. So for example, you can say from this year, this month, from user 1 to 5, anything that's a range value, you can partition by that. You can partition by hash. I didn't understand much how it works, but it creates a formula that it creates a hash for each value and saves with that hash. I'm not sure how it works. That's the one I didn't know, but it's there. Or you can partition by lists. For example, if you have products from that are manufactured, are prime materials, and you can divide it by those two easily using the list partition. One caveat is that the partition, we finished finally this. And now that we run the query, we were on the second or 2 seconds range for the query. Now, by ordering the data, we went down to 100 milliseconds. So it's a real improvement. But in the case of Postgres, new data inserted will be inserted wherever it wants. So you have to run this command, this cluster command, as in maintenance mode. So that's the cost of using this kind of index. In Postgres, at least, you will have to run it, I don't know, every month, 2 months, every day, depending on your data. Of course, the less data they have to sort, the fastest it will be. So if you run it periodically, it will be less time than the time we took right now. So let's go back to the partition. And the partition column must be part of the primary key. If it's not part of the primary key, you cannot partition the table with that criteria. So let's partition our big table. And let's see. So what are we going to do? First, we will be renaming our publications table to publications old. We will create a new publications table with the same fields. And here I'm not creating any primary keys, because if you don't have primary key, you can partition by any field. But for now, we're not going to create a primary key. So you can see, the advantage of the partitions is you can create a new table space, so you can save in a different disk on your computer. You can create a different schema, so it don't clutter your database space, but all the things that you do is on the main table. The query is on the main table. Any changes on the main table will replicate down to all the partition tables. If you create an index on the on the main table, it will create an index, that same index on all the partition tables. So you can create schemas and everything, but I like to having the publications in different schemas, so it's easier to, so it don't clutter all your database space. So here we are creating a schema, a part schema. Then we're going to be creating partitions for from 2023 to 2026. We are creating a range schema. So we are saying from January the 1st, that's inclusive, to January the 1st of 2024, and that's exclusive. So it's greater and equal to the from value and less than the to value. We will create all these partitions. You can create a default partition, and I will explain later why I don't like that. And finally, in the last step, we will be moving all the data from the old table to the new table, and everything is wrapped in a transaction, so it becomes an atomic operation. So if anything goes wrong, we don't have some garbage data there. So let's go back here and let's paste this. Being 10 million rows, going to take a little bit of time. So any questions on partitions right now? We will be using some commands here that I have here, where we can see the partitions names and how much space each partition is using. So we can see that later. Okay, so let's go here. As you can see, we have for each partition approximately the same amount of data. For 2026, since we're in February, it didn't create much data, so it reparted the data evenly on all the dates. So we have that, and we can see this one. And we can see here that old table, it used 1.2 gigabytes of data, and approximately you have the same amount of data. So we didn't lose any data here. If we run the same explain analyze right now on publications, on last year's December data that we were talking about 2 seconds without an index, we haven't created any index yet on this table, and we have a very good time. As you can see here, we have a 100 19 milliseconds. So it improved the time. But now it's the bad time on this kind of partitions. You can create a default partition where all the data that's not fit on any partition table. So if we go here, if we don't, if for any data with a date that doesn't fit on any partition, will go. I don't like that because it defeats the purpose of the partitions. So you will have the data, you can still start having data that's not on a specific table that you want to. So if I say I want to insert into publications, notice that I'm not using publications, part publications, 23, 24, 20, whatever. I'm not using that. Let me see. The ID is serial, so it's how to increment. Let's add a date. Let's add a name. The description is not necessary because it's nullable. So we're going to say values 2027 0101 test. So I'm trying to insert a value that doesn't have that does not have a partition to insert into. So if I run this command, we're going to have an error, no partition in publications key. So that's the caveat of partitioning the table. You have to maintain your table, and once you are reaching the point and you are going, in this case, start needing to insert publications for 2027, you will have to create a partition for 2027. So you saw it had a very good improvement on the speed of the query, but that's the cost. You can have this kind of errors. And you can create indexes. So if we create an index, so if we say we give all the tables, you see I don't have here all the partition tables because we have the publication table here and it's this is partitioned. In this case, it's 0 bytes, but I think it's the part. I don't remember the schema. Let me see very quickly. Partition. Let me see. I don't remember. I don't. I didn't copy that command. But we can see on our queries that we have on the schema partitions all the different partitions. So no data is lost. I didn't delete the table, the original table. So if we go here and let's look at the indexes. We have the index publication dates, but on the publications old table. So we didn't use the index. So let's create that index create index, publication part date on publications. So we're again generating the index. It was much faster than before. And if we so explain, analyze, it's even faster than before. So everything is working. And if we see the index, it automatically created the index for 2023, 24, 25, and 26. So I maintained the main table, and every change went down to the partitions tables. So that's in a glance what I prepared about partitioning, creating indexes, improving in general your databases queries. So any questions, anything you want to add here?
Yeah, sorry, I had another question about the partitions. So what do you do with the original table? Is that deleted, or does that have data in it, or is it just like a pointer to the other tables?
No, I renamed the table first. So I maintain the data on the table. So we have here the publications old table. And so let's see that these are the list of all tables on the public schema. So we have the publications of table that's still there, and we have the publication partition table. So you have both tables. I didn't drop the publication sold. So right now I have a duplicate data. Sorry. I don't know if that answered your question.
So you have the old. Okay, so old is not being used, right?
It's not being used.
Okay, publications is underneath the partition table, and is there data in that table, or does it all go to the split out tables?
So if we say D plus, it gives a little bit more information. We see we have the publications table, that's it. And it has 0 bytes. So you don't have any.
So that moves automatically when you partition?
Yeah, Andres, we can't hear you. So I'll try to answer that until he comes back, Alex. But yeah, when you create the partition table, it moves the data. Yeah, it moved the data into it created the new partitions and it moved the data into them accordingly.
Sorry,
Oh, he's back. Cool.
it came and it somehow messed with the audio. What part you didn't? Where I was stopped. So I was saying that the publications all table it still has all the data. The main publication table doesn't have any data at all. You can see it has 0 bytes, and all the data is on the respective partitions. So that's
Okay, but you query the publication table as is, and then it goes to the correct table, right? Is that right? Okay.
So Postgres and any database system that has partitioning knows that when you're querying the main table, have to look on the partitioned data.
One other thing, if I can add it, what database administrators will do to improve performance even more with partitions is they'll place each individual partition on its own unique disk drive. So that way queries against different partitions aren't colliding with one another.
Yeah, that's what I was saying, that's what I created in a new schema, but you can create it even in a new table space. When you create a table space, you assign the specific disk route where you're going to be using that table. So, for example, and now, if I have all data, for example, I don't need to keep the data for the year 2000. I can just remove that table from that specific partition from the database, and I'm freeing data space without much without a problem on deleting everything on that table. For example, I can delete part of publications 2023, and I will only be deleting that specific partition. So that's it's a specific idea is good to. The other improvement you have, once you have a backup, backups usually are incremental. So if you have a very big data table and you made changes to that big table, the whole big table will be backed up. Now that we have divided that big table on different partitions, the only partition that will be backed up in the next backup will be the partition it was modified, improving the disk space you need to have for backup. If you're doing a full backup, you will not see any improvements, but for incremental backups, you will see noticeable improvements.
If I can add, Andres, another interesting concept is tiered storage. I've seen cases where, if we just use this example, since rotating disk is typically cheaper than like a solid state disk, I've seen cases in the past where DBAs would put the current year's data on an SSD, but prior year's data would be on rotating disk. And so what they were doing was balancing the need for, high performance for the current, most recent data, balancing that against the cost of storage for older data.
One important thing to notice, we're scaling vertically here. So if we need more machine, we will need to add more disks. We will need to add more machine. Whatever, we're still using one machine. There's a lot of can of worms when we start speaking about the replications and sharding and whatnot. That's a different topic. We're using just one machine here. So in the databases we use on Railway on all the free databases we have, you can use this. In the future, we will be talking about data replication, and we will see that it will be hard for me to make a demo because we need to have different machines, and we have to have many other processes that have to be in place. So, any more questions from anybody about this topic or any other topic whatsoever?
Well, just a thank you, Andres, because I don't think anyone else knows this, but Andres is actually not feeling well at all. And he went ahead and hosted this roundtable rather than rescheduling. So I think if we look in the dictionary under dedication, we'll see your photograph, Andres.
Thanks, Jim. So if there's no more questions, we will be rounding up this now. So last call. Okay, thank you, everybody. Hopefully you found this information useful, and you can add this to your bag of knowledge. Yeah. Bye, everybody.
Bye-bye. Thanks, Andres.
Thank you, Andres.